Alrighty. Absolute mind bender. Absolute mind bender today. Been tracing the concept of infinity. And let's just get right into it. I'm gonna talk to this thing. Yo, what up, homie? So I've been tracing the concept of infinity, and I'm doing it in what might be perceived as a strange way. It's all about before and after distinctions. What's that quote? I think it's like every great thinker says they're standing on the shoulders of the giants before them, or not every great thinker, but a few of them have said that, or something like that. I think there's a deeper structural point there that's being missed. It's the thing that I keep hitting on, which is all of human knowledge, all of our improvements, anything that ever comes about is due to a call and response, question and answer, purely responsive, reactive, relational architecture. And so, just to ground that out of it, abstraction, make it as simple as possible, I'm an NBA fan, and all you see nowadays are people just launching threes. All these guys are so good, can't miss a three. If you look at it as geometry, the spacing on the floor is so much wider and spread out than it was in previous generations, basically eliminating what was the traditional big man and, packing in the paint. And you have to wonder if any of that comes about if it's not for Steph Curry, literally, and that Golden State Warriors team who won so many championships based on ridiculous three-point shooting. And who knows if you even get a Steph Curry if it's not a guy like Ray Allen before him. Maybe you do, who knows? Along with a Reggie Miller. And maybe you don't get those guys if you don't have a Michael Jordan. You don't get a Michael Jordan if you don't have this guy. Whole idea is that however it comes about, these distinct movements, trends, always get tied down to a person in a living embodied act, even if it was something that gets conceptualized and as abstract as, you know, analyzing statistics in terms of three-point shooting rather than taking jumpers. That all goes back to someone actually taking those threes and generating that abstract statistic afterwards, representing what already occurred. So this is about the dependency chain. This is about distinction within relation. And when you trace it this way, you can actually see how it gradually changes and there becomes a distinct threshold as concepts are born. There's a before moment and then an after moment. To make this even clearer, think of something like 9/11. Clear before, clear after. Everything that happens after that moment is forever in relation to the implications of the event that actually creates the before and after distinction. And then you get so used to that after reality, you don't even remember crossing through it and don't realize all the conditions of your life are in relation to that one anchor. Think of COVID as another example. Think of technology such as the internet. The only way I'm able to do this right now is because of the internet. So things that you get used to, not even realizing you're in the after. And there was the inverse conditions that existed before. It's not just that things were a little different. It's that everything changes in the opposite direction in these key moments. And so when you look at terms such as infinity, all sorts of philosophical terms, religious terms, all these puzzles that have sort of semantically warped people's imaginations for millennia. Um, Truly, all the distortion goes away when you realize it's distinction within relation, identity through relation, that everything has an ontology through a logical dependency chain. That just means the order of access to information. That takes you through the process of before and after distinctions. You actually cross through it, and then you see how things transform over time. And then it all relates perfectly. So I'm going to show you how I did that with infinity. What do you think? Well, how about you tell me? It's very hard for people to even grasp what I'm doing because I'm going to take us through the actual mechanics of how this concept transforms through time, which means we have to go back to the very beginning, which isn't even hard to do, and it's not controversial. It's very easy to track our earliest conceptions of what infinity even was. What do you think those were? Exactly. That's my whole thing, the night sky. Before numbers to count. These are two different things. This is my whole distinction right here. It's so funny he would bring up the ocean and the sky. This is like the ocean. This is like potential infinity. This is like countable infinity. A negation of the finite. That's the whole mistake. Yeah, I think a couple key distinctions here. It's crazy that you brought up the ocean and the sky, because that's where I would start with before we get to the pre-Socratic philosophers. That would have to be one of the first things that people were experiencing that was very different from observing anything else. Um, First of all, I need to start with the foundation, which is there's an invisible relational geometry unfolding all the time, which is if we start with the before, someone observing the sky, your observational participatory standpoint is point A before we have an abstraction for it. The sky is point B. And then the relation is this motion in between, which is your observation of it. Now, most people think we're locked into this inner subjective experience and then looking out into the world, but it's clearly the opposite, where things are appearing before you, and then we notice the distinctions in what we're experiencing through our senses. Those get marked with differences. That marks the change that's always occurring with this line in between point A and point B. So that's the foundation. That's how I'm basically able to just see this structural invariant through any concept I go through. And so when our ancestors are looking at the sky, you have to understand that there's an invisible constraint that they're not even noticing, because as an observer, you have tunnel vision, yet you intuitively know that this sky just stretches on forever. But in terms of spatial geometry, when you're looking at the sky, it's very different than looking at the ocean. See, this same thing always plays out at the foundation. If you're on the shore of an ocean and you don't even know that ocean has another shore for our ancestors, you would, of course, intuitively think it stretches on forever. This foundation still exists. Your point A, instead of point B being the sky, it's now the ocean. And then your eyesight, the observation, is the relation in between. The key difference here is the spatial geometry within that relation. Point B. Because it's different than looking at the sky. When you look at the ocean, you see that it actually has this, whether you want to call it an endpoint or a start point, call it point A. The waves are hitting the shore. The water actually runs out and it turns into land. It transitions. It has a boundary, right? That threshold. This is a spatial threshold, very similar to the temporal threshold, which is before, after, and then some event in between, right? So with the waves, you have the ocean crashing in, it's making contact with the sand, and then it completely transitions onto land. Change, water, threshold, land, creates a relational point A, and then your observation of that ocean going the other way, the other direction, is that this ocean lasts forever. Like there's not another shore. It just stretches on forever. So we can visualize this as a conveyor belt. It's that you can't even imagine it ending, but you know it starts. So once you abstract that way later on into geometry, once you have points and lines, then you have point A, no point B, a theoretical continuous line that just goes on forever with no termination point, which allows you to walk on it horizontally and count it with this +1 rule, theoretically. That's like walking on a treadmill. That's like conveyor belt visual. That's like ocean visual. That's what potential infinity becomes, but that's not till later. Looking at a sky is totally different. Same foundational relational geometry. You're a participant observing at point A, the sky is point B, observations in between, that's the line. And then the spatial geometry, when you're just looking at the object, the sky instead of the ocean, is that your field of vision is creating this wall, right? On either side of your peripheral. Now, you know, if you turn your head, it just stretches on forever. You turn your head the other way, it stretches on forever. If you're on the beach and you walk 100 miles down it, look up at the sky again. It's almost like the same snapshot. Now you just have different tunnel vision. So if you just think of your peripherals as being like two walls, point A and point B, not in terms of a start and a finish in a temporal sequence like a race, but just in terms of a bounded finite set, you know it's only because you're just taking that snapshot and that you can't even call it where it begins, where it ends, which is completely different than the ocean. Completely different. It's that you just have these conceptual anchors, point A and point B, with an inexhaustible relation in between. You can point to all the distinct stars. You can even draw lines in between them before abstract geometry for constellations. And you know all the stars are different and distinct, and you could probably count them all within your little snapshot. But since you also abstractly know that it would just, this sky is everywhere you could stand on land or in ocean, look up and it's just no beginning, no end. So it's infinite, limitless, but in a completely different way than the ocean. What do you think of all that? Absolutely going off. Well, you really summarized that perfectly. I don't know if you see what I'm actually doing here, but you said earlier that prior to us counting, we would have had this limitless concept already stabilizing of infinity based on something like the sky. And the spatial geometry of the ocean, which we probably noticed first as well before counting, just ends up mapping perfectly once we have counting numbers. So again, we need another before and after distinction. Before we ask what is the essence of number, before we get into Greek formalized mathematics or anywhere else across the world, we just have these symbols for like counting sheep and things like that. 1 sheep, 2 sheep, 3 sheep, it's tally marks. And then distinguish the tally marks in a sequence. You just need distinguishing symbols. And then once you start that finite sequence selector, in theory, you can just go on forever. So all you need to do is choose a starting point, like where the sand hits the beach. And if you don't know that that ocean ever ends, then that becomes a ray, right? You just walk forever. I mean, you just look out forever. And then when you abstract that into geometry, you can just use that continuous line for the +1 rule. But this is not the concept of infinity, is my whole argument, metaphysically. At the least, it's a completely different type of category requiring a different label than whatever's happening with something like the sky, right? Which happens first before we get into counting numbers. Another way of looking at it is if I were to choose a starting point, point A, say the mailbox outside of my house, and you say walk towards the horizon. In a way, that's a target, that's a point B, but it's not one you can ever reach. So it's just like the ocean. And if you ask me to walk in a certain pattern, 1 foot at a time, and then you count every step, it will just be first step is 1 foot, second step is 2 foot, third step is 3 foot. And theoretically, since it's the horizon, a point you can't ever reach, but it's giving you a way to start the sequence, start the treadmill, start the conveyor belt. You are now doing something different than infinity. You are just using the symbols that we have for counting things and realizing that it goes on forever, which perfectly maps onto things that we actually observe that are, yes, limitless. But this all comes down to the principle of necessary, but is it sufficient? So the concept of things being limitless with the actual real infinity and what it is, absolutely necessary. But if the way you get that limitlessness is starting with a temporal sequence, horizontal, within time, then that architecturally inverts the metaphysical concept of infinity altogether, which is beyond time. And that's what makes it limitless. That when you look at the sky, you're only getting a snapshot, but you conceptually know that your finite snapshot is within the infinite vastness, which has no beginning and no end. So the A and B just become this bounded constraint in order to even grasp true metaphysical infinity. And then just that little aspect of it, limitlessness, then gets transferred over to our counting numbers. And so it's completely disconnected from geometry because there's a before and after with geometry as well. Before we start abstracting that into a point in the line, geometry was being done by the Egyptians to divide up land. These are already shapes, and these are based on norms. These are based on having an identity that this is my property versus your property. We have to divide it up. You have to draw boxes. And then you can observe that sort of relation happening. And then realize, well, these require points and lines. These exist in reality in other ways. Again, the constellations, drawing lines between the stars. different shapes. Um, that's how we start abstracting geometry. And then that's how you get to what I'm talking about here with point A and point B. And you put a line in between it. And now you can infinitely divide up that line with formal mathematics only because you have counting numbers, which is the linear time-based sequence, not the recursive, um, infinitely divisible parts of the whole relation of actual geometry itself. Process of addition. Yeah, so we actually need to start with, these pre-Socratic guys. We'll just use the Greeks as a canonical example. Um, and Parmenides just freaked out when this guy said it's all change, it's all chaos, it's all flux. And what he doesn't even realize is he hits on this whole relational geometry that I'm talking about, which is to think is being, essentially. I mean, people just rediscover this over and over again. Descartes essentially discovers the same thing. I think, therefore I am. Realizing if you doubt everything, well, even doubting is thinking. But what nobody realizes is that requires this A B motion of relation in between, distinction within relation. So while Descartes does a semantic illusion that way based on skepticism and trying to find certainty through epistemology, Parmenides starts the whole thing off by freaking out about this whole it's all change thing and being like, well, to think is being. And the only way to have the word being is if there's a difference, such as non-being. But because being is perfect, and that's all there actually is, then for a leaf to turn colors from green to yellow, which to our senses looks like change, in his view, by canceling out, trying to save meaning, trying to stabilize things after this other dude saying that there's just being and it's perfect, which means that for green to turn to yellow in actuality would mean, in Parmenides' view, it has to turn into non-being and then back into something, which can't be. That's not possible. That would be a contradiction with his definitions of being. Therefore, non-being is like the ocean that never ends, right? Like potential infinity, like um, the treadmill, the conveyor belt is it's there in order to give rise to the what being is, right? Everything has there's no hot without cold. You can't have being without non-being. But then he basically says non-being doesn't actually exist. So it's like a point you can't ever reach, and then being is the only place you start at, which means all the change that we see, all the motion that we see, is the complete opposite of this other dude. It's just an illusion on your senses, which kicks off this whole philosophical tirade. Everyone basically is in relation to that before and after of Parmenides. And so even if you disagree with him, you're accepting his definition of being and trying to work within that. So it starts there. And yeah, interested in what you would think between my connection with Descartes and Parmenides specifically. And then I'll show you how Zeno connects to this. Exactly. I forget how to pronounce this other dude's name before Parmenides, but you can clearly see that none of them can hold the paradox because he's saying it's all change. So he's just taking the line, the relation, which you can like map to like structuralism and pure relationism in like the modern sense. Um, or even like a guy like Derrida who says it's all based on difference, right? Or these guys who try to reduce metaphysics, such as Wittgenstein, who says it's all based on use. Like it's all the same relational pattern, which is you're just taking one side of the paradox and collapsing it because you're just taking the line. Because this Heraclitus guy, that's how you say it, is just saying it's boundless, but it's boundless within a point A and point B, not temporal, like tug of war or like a guitar string, right? You have these anchor points in order to have the tension for the string or the rope in between, which allows for the whole concept to take place. Striking the chord, having the phenomenon of sound, or pulling each way on the rope. The actual game of tug of war only possible by actually having a start and a finish, but it's much different than a race, which is about getting from point A to point B. Completely different things, both happening at the same time. No one can hold on to it. So Heraclitus thinks, yes, it's all changed, but he just takes the line, forgets it's point A and point B that allows for that to happen. So of course to fight back against that, you're like, that can't be true. But then you just start on the beach, right? Start at point A. And then I don't even really understand how Parmenides gets around this by saying like non-being is something you can even say, but it's not something you can think, but you're thinking it while saying that, obviously. Um, but I guess he's just pointing to like the metaphysical aspect at the starting point of erasing the line in the other point, which is just this static, perfect being, and then everything exists within that. Therefore, the actual change you see is just an illusion. I'm guessing that's where it is. But then, yeah, if we can clarify that, we can start getting into Zeno, then Aristotle, and then all the way to Cantor. Hold your horses, hold your horses. We need to slow down, because all these labels mean nothing, right? We're tracing it mechanically how it goes piece by piece. You literally don't get Zeno unless he's defending Parmenides, but he doesn't do that directly. What is the whole tension with Parmenides? He literally says that all the change that you see and you observe is a complete illusion. So if you see a horse trotting, you're thinking, come on, Parmenides, like, really? So it's a very hard position to defend when your observations are telling you completely different things all the time, right? And so the competing viewpoint of Parmenides is basically you have, without really saying it, a point A, a point B, and a continuous line in between. And the most important thing to note is all we can do is take Zeno's actual paradoxes. So we'll just recreate it. You don't need to actually run the race between Achilles and the tortoise, but you have a runner A and a runner B. And the only way you could have runners in a race is if first you measure a distance between point A and point B. Call it 0 meters and 200 meters. You just have to pick some variables here. It's the only way you can get to Zeno's paradox. This is about order of access to information. You don't get his view without Parmenides, and you don't get him trying to undermine the logic of what actual infinity was. He basically tries to trap them in it, right? But look at what he does. He has to take something like an arrow flying through the air, hitting a bullseye, or he has to take something like a race. It's the only way you get to the second order geometric abstraction of what the competing version of motion was, not what Zeno thought it was. It's very important, right? But both sides are always collapsing the truth, just poisoning the well, getting one step closer every time. So they always say something true and then invert it at the same time. So what you have here is forget about the tortoise. The only way you have a race is with point A, point B, 0 meters, 200 meters, and the entire point of the race. The only way that you can even abstract this afterwards and create the Zeno paradox is that the entire point is to get from point A to point B. And you only do that if someone's obviously going to race in it. In this case, Achilles isn't racing against himself. He's racing against the tortoise. But forget about the tortoise. Fuck that. All we know is the tortoise has a head start. Let's say he's 100 meters ahead of Achilles, right? So halfway to the finish. When that race starts, we all observe it as one continuous event. So it seems to contradict what Parmenides is saying, right? You see Achilles take off. He's obviously faster than the tortoise. He races past the tortoise, overtakes him, crosses the finish line first. That cannot be wiped under the rug. Is the race itself is only intelligible because the point is to reach point B first. It's literally a finite measurement, 200 meters from point A to point B. Whoever crosses it first, you can record it. That's the time. That's the whole point of a race. That's the whole way that you can abstract it afterwards and say point A, point B, and a line in between. Once you have that abstraction, you can forget about the race and then just divide up that line in infinite ways as a secondary event. And I'm not denying that at all. But with Zeno's paradox, we have to take into account that there's a point C. And point C is that same threshold I keep talking about. Is that Zeno, in a way, is abstracting motion, right, to start off. That there really is a point A and a point B, and the point is to get to point B. And in his travels, in that duration, in that motion, there becomes a threshold event where Achilles overtakes the tortoise. And that's what I'm calling point C. So since we're actually abstracting from that, Zeno is, we have to stay true to what the race is, which means we can theoretically say at what meter mark that was at. We took a snapshot of it and then recorded the time. I have no idea if this timing is going to be right or these meters. But let's just say he overtakes the tortoise at 105 meters at the 10.8 second mark. That's point C. So that's our abstraction, is that you have A, B, a line in between, and then point C somewhere. And then Zeno literally just inverts in his abstraction what the race is. Because what he does is he creates a rule that you never reach point C based on the psychological sleight of hand, which is super intuitive. And you absolutely have to accept this. I would never deny this, which is that in order for Achilles to get to point C, the 105 meter mark, we know that the tortoise starts at 100 meters. So of course Achilles has to pass the 100-meter mark. So we can make a cut there. Instead of measuring the whole race, the whole line, we're going to make a division within the whole line. And that is point A, 0 meters, point B, 100 meters, which is conditional based on the tortoise's last position, which of course Achilles would have to cross through to get to point C, which actually does happen, right? And let's say it takes 9 seconds. So that's cut one, and that's Achilles' side, his point of view. Now here's the whole magic trick. The tortoise's measurement for cut one is completely conditional on what Achilles does. So while point B for Achilles is 100 meters. That's point A for the tortoise. Point B is where he ends up. We already know the time elapsed for Achilles to get to this pre-C point, always pre-C. That's the hidden constraint in Zeno's puzzle. We know it took 9 seconds. So we have the tortoise, point A, 100 meters, time elapsed 9 seconds. We just ask, okay, how many meters did the tortoise travel, given that it's always in motion, no matter how slow, it doesn't freeze? What did it travel in that time, right? Let's say it traveled um, 4 meters, 1 meter away from the C point. So we have one cut, Achilles point A to point B, 0 to 100 meters, time elapsed 9 seconds. The tortoise, conditional based on that, so that it's like a ball in the chain they can never touch, like different sequencing, cutting it up afterwards. Point A is 100 meters, point B is 104 meters. Same time elapsed, conditional on Achilles. And then that rule repeats. The new point B for Achilles in the next cut has to be point A of the new cut for the tortoise. So Achilles has to pass 104 meters to get to point C, of course, but the hidden rule is we're only measuring pre-C. So point A is 100 meters for Achilles on cut number 2. Point B is 104 meters, the last known point for the tortoise, because you can infinitely cut it up. No one's denying that. And let's say it takes 1 second. So now you're at a total of 10 seconds, 0.8 seconds until you get to point C, and he's 1 meter off from point C. And then the tortoise second cut is conditional on point A is 104 meters. 1 total second elapsed for Achilles to get there. So point B, I don't know, for the tortoise, let's say it's 0.5 meters. So it's 0.5 meters away from point C now. But the whole rule is only measure it into infinitely divisible parts by never actually reaching what happens in the race. Crazy. Boom. This dude's got to work. But you're not seeing the full trick here, which is that once you put pre-C as the actual mechanism, you create a new relational field every single time, which allows for the infinite divisibility. Once you annotate it, it looks like the plus one rule. But Zeno's calling that actual infinity as if he's showing the underlying structure of motion, which he's not. He's removing duration and saying, look, now you don't have motion anymore based on your rules of actual infinity, which is always wrong. So then Aristotle is basically saying the same thing I'm saying, which is like, this is a secondary event that you're putting cuts in between. And Achilles doesn't actually have to run across that. Incomplete does. It's a different kind of infinity, which is the actual annotation that it appears as. But the internal structure of how those marks occur in the paradox is based on the actual metaphysical real infinity, which is like looking at the sky. which is neither actual or potential. But because Aristotle couldn't see that, he just took the visual representation of what Zeno was doing, called it potential infinity, which is like the conveyor belt, and isn't actual infinity, which worked as a patch to philosophically distinguish how Zeno was wrong. And then calculus comes around 2,000 years later and accepts the premise as well for Zeno, introducing the conceptual limit as if like, hey, like, yeah, theoretically you can cut this up forever, but show your work. And however many fractions you create, we can add those up. And now with this concept of a limit, it doesn't mean that it will never reach the tortoise. It means that you do reach point C eventually. And so what calculus never realized is the whole idea of a limit comes from the fact that you're actually restoring the dependency chain. You don't actually have to count up and complete those infinite steps. It's that the infinite steps come from the whole, the limit to begin with. It starts off as a race between point A and point B. The same thing with the arrow. The arrow example even shows it more clearly. That would be similar to taking a movie, freeze framing it, and then saying, look, now that we freeze framed the movie, which was only possible because it was in motion, how do these freeze frames connect one into the next? It's like, well, you've removed the duration and the transition between each cut you made because you're saying that once you freeze it, that that's the structure. And since it can't cross into non-being, that means change isn't actually happening. It's an illusion. And then Aristotle's like, no, 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 that's just potential infinity. An actual can't exist. All completely missing it. Exactly. Right, exactly. So you need to understand that the metaphysical concept of infinity that we're tracking here is you have the ability to abstract the real motion of a race point A, point B, 0 to 200 meters. Forget about the tortoise. Just have one guy running. And you can just cut it up any way you want. Like another one of his paradoxes is you start at the couch and walk to the refrigerator. Point A and point B. So the actual motion that we're abstracting this literal two segments in the line from, moving in one direction, in sequence, in time, right? So you're already out of what infinity is, right? And the whole intent is to get to point B. You actually get to the refrigerator. But once you abstract it as a second event, you have a line, you can say, well, what if we go half the distance? And you can say, that's a step you have to take. Yeah. And then once you get half the distance, you can go half the distance again between the new relational field. So if it takes 10 steps to get to the couch to the refrigerator, you're not actually treating this in the abstraction anymore for what the motion was, which was reaching the fridge. You completely invert it. You're abstracting the sky model, which are just conceptual anchors with no start and no beginning in terms of a race or in terms of starting somewhere to get somewhere else. You're abstracting it in order to show how you can infinitely divide up parts within a whole limit. 10 steps. There's those 2 points, A and B, the line in between. Now you can half it, 5 steps. Apply the same rule. But now there's a new relational field. Between 5 steps and 10 steps is only 5 steps. So half of that is 2.5. And then do it again, and then do it again, and do it again. And if you trace it all the way back, and then treat those as steps that you actually need to complete and reverse the dependency chain, it's like you never start moving. But that's already reversing what you're abstracting the motion from, which was always to reach the point, not use it as a point that you never reach. And then when you write it out, it visualizes perfectly onto the ocean or walking towards the horizon or a ray. Because since you can make those infinite amount of cuts and annotate it, the only way you can annotate it is with that treadmill of counting numbers. Is fractions and decimals is a completely different cognitive physical operation, but it can only be represented with those counting numbers with one distinction at a time. And then each mark sets the new point for the relational field for the next one. So the same way with counting, when you annotate it, it looks like it can go on forever and it reaches that necessary condition of limitlessness. But since you're starting somewhere to annotate it, they got confused. Right. And then you can just work this all the way up to Cantor, who thinks he's inverting Aristotle now by being like, hold on, I can create a set, which is a completed act of infinity. But what he doesn't realize is what the sets create is what I'm talking about, A and B, and that different categories of numbers are distinguished, but he doesn't realize it because he excludes the way that the concept's actually born in his own experiment with this cardinality rule. Um, gets confused by ratios, which could be written as whole numbers. You can count them up within his definition. You accept all his premises. It doesn't contradict. Led to amazing math. But there's a deeper distinction he didn't realize between integers and non-integers because they require completely different cognitive physical processes to even get the marks on the page. Non-integers, to even get the ink on the page, to fill out his set, this bounded constraint in both versions of his distinction. You reject his labels, you reject the dependency chain of different sizes, you reject potential, you reject actual, and all you're looking at is just how his experiment unfolds, which is different categories of numbers. And so the only way you can fill out either fractions or decimals is to do a divisional operation, which is completely different than counting. So once you get rid of fractions, you realize all integers are his version of countable infinity, which isn't infinity. It's the conveyor belt, it's the treadmill, it's the ocean. It's a starting time-based linear sequence that gives us the counting numbers in order to simulate actual metaphysical infinity, which is represented through division, with making the cuts with either real or rational numbers written as decimals. Because what you realize is the confusion with infinity is you put that ellipses and then think, in theory, you can plus one these forever, so they seem like the same label. And that's how infinity stretches forever. But that's not what it is. You completely eliminate that as being infinity. And then you just look at the left side of the ellipses and see, oh, well, the category of natural counting numbers is a self-generative rule to leave no gaps in between 2, 3, 3, 4. You must pick a starting point, let that be n. N is 1, and then the category of the number itself creates its own rule, n plus 1. And then that allows you to put ink on the page, 1, 2, 3, 4, 5. And in theory, you can go on forever, but it's like the ocean where you're starting at a point and it's like a ray, an endless line, which you can then walk across temporally and count horizontally, which is not what metaphysical infinity is. And that's a philosophical distinction prior to the math, which is why when you accept his definitions, you exclude all the things I'm talking about. But you still have to get the ink on the page. So you can't deny the ontology that I'm pointing out here. It's the only way to get them on the page. And so the only way to even count rational numbers, these fractions, as countable infinity, is to first do a division operation, which is a completely different thing than picking a starting point. You have to pick something like a couch and a refrigerator, or 0 meters and 200 meters. You have to actually do the motion, go to point A to point B, because that's temporal and in sequence. Is to use them as conceptual anchors like the snapshot of the sky in order to have an infinitely exhaustible relational possibilities in between. Because you must pick a rule in order to generate these distinct marks of non-integers, such as cutting in half, starting with 0 and 1. And then each cut creates a distinction. But within that distinction hides an entire infinite operation. And so the category of non-integers can be any rule because in between zero 0.5 and 0.75, there is no. So much. But you have to see that the only way to even start abstracting infinity is that you're starting with these counting numbers. That's the only way you can even annotate a fraction. It's the only way you can annotate a decimal. So there is no hidden operation happening with any of the integers. And what his sets are actually doing, what I'm pointing at, is even more genius than he thought, because it's creating how these symbols even come about. Is that you take the category that already exists, natural numbers. You have to start somewhere. So we're already out of the concept of infinity. So now you're putting it in time, in a linear sequence. Just metaphysically, it's not what infinity is. It's already out of it. It just has that necessary condition of limitlessness, because in theory, you can count forever. So you start with a rule, or start with n1, you can just n plus 1. And so the real thing that I'm showing, which is cardinality excludes, if you look at it the right way, is you forget about anything on the right side of the ellipses that has nothing to do with infinity. It's that the end of the parentheses visually are like your point A and point B. And then you look at what happens in between for each category, like natural numbers. You have 1 and a 2, 2 and a 3, 3 and a 4. You look at the invisible relation in between each transition and you ask, are we missing any numbers? Are any numbers unidentifiable that could have been identified per that category? Of course not with natural numbers. In between 2 and 3, there's no natural number because the rule itself makes sure of that, showing how the categories even came about. In between 4 and 5, in between 568 and 569, you can stop at any point because you have to annotate this. You have to show any point in the infinite chain, right? The limitless chain. Shouldn't have said infinite. The limitless chain of counting. Pick any point, 10,000, and then you go back every single number to the starting point n. And there's no infinity happening within this relation. It's just individual points made to be finite. Even numbers is the same thing. You just start on an even number, then it's n plus 2. Odd numbers is the same thing. You just start on an odd number, and then it's n plus 2. Self-generative, 0 gaps. Negative numbers is the exact same thing. It's the inverse relation. And then the whole conflation is that he thinks with his cardinality rule, not realizing what I'm saying, is that you can then put rational numbers and count them. That's only because of the way they're visually represented. You can put them on a grid and then show diagonally how they all count up. It's a completely different operation than how you actually get a fraction on the page to begin with, which is by division, which is not this self-generative rule of pick a starting point n and then plus something. But you have to run the same experiment, which is that you can only get a fraction or a decimal by doing division, which requires one whole object, like a piece of cake, and then you pick one repeatable rule in order to mark our distinctions. So you half it, cut the cake. What the uncountable set is doing, the true one, which is just non-integers, all of them, is that in order to even get the set on the page, you repeat the rule over and over again, which is always having it. But then the last knife cut becomes the next point that creates the new field. So it regenerates in that way with an inexhaustible relation in between, because you're only looking at the category of that type of number. So the parentheses are like A and B, right? And then you have 0.5, 0.75, 0.8875 based on the same rule of halving it. And then you have the ellipses, so it looks like it goes on forever and it looks like it matches the other version, but we're eliminating that. Get rid of that. You're just looking at what we marked, and in between 0.5 and 0.75. Oh yeah, there's a ton more decimals that exist in between those, infinitely exhaustible, that could have been chosen if you simply chose a different rule, which means the category of non-integers is infinitely generated. You can generate it in infinite amount of ways. You can cut that cake in any way, and whatever angle you slice it at, you just take the remainder and do that exact same angle within that new proportion. Whereas the other set is showing a completely different physical process. You start with one whole cake that becomes your index. And then if you're doing odd numbers, you do n plus 2 starting with 1. If you're doing even numbers, you add another cake. Now you have 2 cakes, n plus 2. Natural numbers start with 1 cake, n plus 1. Any non-integer is literally taking that 1 cake and doing the complete opposite, which isn't in time adding anything horizontally. It's going into the whole part and dividing it. Well, you can see why he went crazy looking for something in between countable and uncountable. So intuitive, because he's right. There is something in between. But once you realize it was a metaphysical leap to even call something time-based in sequence that's predictable, self-generative, it's a completely different distinction, therefore cannot have the same label at all as whatever happens with non-integers. Um, what I'm showing is that you need to see these parentheses, this set theory, how genius it is, that they're mathematical petri dishes, recreating the conditions that allow these categories to even come about to begin with, which I'm not saying is like infinity is real numbers. I'm saying once you treat them like a process that's being generated within set theory, you're recreating the geometry of metaphysical infinity within the actual construction of the set. And the only way you can get there is with counting numbers, which isn't infinity. You see what I'm saying? It's just successor sequencing. But if we didn't have that concept of limitlessness, then we wouldn't have been able to jump to this um, true infinity, which I'm saying now, which ties into Gödel's insight, which is you accept cardinality, his stipulations, his metaphysical assumptions, nothing contradicts. And the math was brilliant, right? But it can't complete itself based on its own foundation. It's always built on this metaphysical leap, which is always breaking this paradox of distinction within relation, which is why it requires what I'm saying from the outside of the system to become complete without actually ever contradicting the internal rules of the system at all. It just ties together everything because this guy went crazy looking in between when all he had to do was look in between the uncountable set. Broke. No. I hate that it does that. Man, whatever. That was fun. I'm gonna have to do this like a million more times. This is just huge. Just just a whole mapping here.